One of the question that normally asked is uniform circular motion is accelerated motion. How do you say so? Now we see that the angular velocity is uniform, but still it's an accelerated motion. Why? Now in order to understand that, we have got to go to scalars and vectors. In terms of scalars, we know it's only magnitude with which we are concerned. But whenever we are talking in terms of vector, it is magnitude as well as direction. Alright? Now here what happens, we are talking in terms of angular velocity. So we find that at this point, and at this point, at all variable points, it has variable direction. Now since at all the points it has variable direction, so it becomes variable velocity. And we know that variable velocity, that is difference in velocity divided by difference in time, that is d omega upon dt is acceleration. Alright, so it would be omega 1, omega 2, omega 3, omega 4, omega, so it would be having variable angular velocity. So difference in angular velocity over difference in time, so at different interval of time it will have different direction, so dt, so at different time having different direction, so having different angular velocity, so different angular velocity, so d omega over dt would be acceleration. So uniform circular motion is accelerated motion only because of its change in direction. Alright, at every point it changes its direction. So alright, though the speed is same, if I say 3 rotations per second, so it would be 3 rotations per second, but the direction would be keeping on changing. Alright, this is one aspect. Now yet another aspect that you are supposed to know is suppose we are talking of radial acceleration, alright, centripetal acceleration, radial acceleration, and we are talking about tangential acceleration. So the angle between them is 90 degree. So at this point the particle is facing radial acceleration as well as tangential acceleration, which are at 90 degrees to each other. And we know as per law of parallelogram that we had done in 11th, we know that r is equal to, now here this is one acceleration, that is one acceleration. Now acceleration itself, we know force is equal to mass into acceleration. So here we are not considering mass, we are just considering in terms of acceleration. So acceleration, so it would be a r square plus a d square plus 2 a r a d cos, the angle is pi by 2, 90 degrees, right? Now since it is 90 degree, we know cos pi by 2 is 0, so this disappears. So the acceleration here, I had to put acceleration, so the acceleration would be a root of a r square plus a t square. This is yet another formula which you have got to keep in mind. Alright, though we will, in our next video we would be dealing with formula, linear formula converted into rotational formula. Alright, okay, so here in this case here, so if you are asked to find acceleration for a circular motion, then you are supposed to know radial acceleration and tangential acceleration, because the actual acceleration is root of square of radial acceleration plus square of tangential acceleration. Okay, so it's sum of square of radial acceleration and tangential acceleration. Okay, all right, so let's see in our next video what all we have. All right.